Now let me get quickly to 2000, the year 2000. In the second reassessment that I'm talking about, I'll move a little quicker. The second reassessment, the figures are different. Now, EPA reports instead of 120 billionths of a gram per day in our diet, there is only 70, because actions have been taken and sources have been more controlled and so on. So we're getting less dioxin in our diet. But the consequences of that now, instead of having a lifetime risk of 500 to 1,000, the lifetime risk is 1,000 to 10,000. Tenfold higher, despite the fact that we're eating less dioxin. Because some of the research was reevaluated, and it looks as though the problem is worse than it was. Now, let me show you what this means. EPA has now, it took them until 1999 to promulgate controls over the main sources. I should tell you, incinerators of various kinds are the main sources. And there are some others too. Cement kilns that burn hazardous waste, and so on. The EPA has now instituted regulations. They worked out what is the maximum achievable control technology. And you have to apply it. Now, what we know a good deal about what happens in an incinerator, and this is something that I've talked with Bob Kindred about, and it's very important to understand. Dioxin is not in the trash. It may be a little bit, but unless someone is putting something odd into the trash, it's not there. And the question of destroying dioxin in the furnace is irrelevant. The way we now know that dioxin is literally synthesized in the cooler parts of the incinerator. What happens is, when you're burning something, it's got carbon in it, and there is some residue of carbonaceous material that gets out into the furnace, gases, and so does the chlorine. And it's now known that at a temperature of about 300 to 400 degrees centigrade, the chlorine attaches to various particles and forms dioxin. Put it this way: every time you turn on an incinerator, the world has more dioxin in it than it had before. How do you control it? Well, you try to trap it after it's been made, although now that we know just where it's formed, the new control systems try to regulate this 300 to 400 degree temperature in such a way by quickly cooling it so that you pass through that temperature so quickly that there's not much time to make the dioxin. So the point is this: when you hear, this is such a good hot furnace, it destroys dioxin, that's irrelevant. The question is, what does it make in the cooler parts? And the Ames incinerator has got to be doing it. And the way I know it is that Bob Kindred sent me a big report done by an EPA laboratory in 1978, right? I think it was 78. And they have a list. They didn't measure for dioxin, but they have a list of organic chlorine compounds that they had detected, including furan, which is the chlorinated molecule without the chlorine on it yet. In other words, the dibenzo chlorinated furan, they didn't detect. They weren't looking for it, but they found this one. In other words, it's absolutely clear that in 1978, anyway, the Ames incinerator was generating chlorinated organic material, much of which was far less stable than dioxin. And there had to be dioxin there. Well, anyway, that's where we're at. And what EPA has done is to promulgate a control strategy. Now, what else could you do? You can't put an umbrella over Nunavut or over the farm in Wisconsin. So there are really only two things you can do. You can try to do something on the source, or, and EPA is considering this as another strategy, and I was told by one of the policy people they have a dual strategy. One is to put controls on the incinerator, and the other is to get people to eat less animal fat. And my answer to that is good luck. Because the government's been trying to get people to eat less animal fat. And the latest figures I've seen show that we're eating more animal fat than we were 10 years ago. And besides, it really can't be done, for example, with children. Every pediatrician will tell you that a child up to the age of 2 must have animal fat, either in the form of mother's milk or cow's milk or sheep's milk, for nutritional reasons. The other thing about it is there have been diets set up by various doctors who make a living at this, I guess, and some of them really restrict animal fat. And I've looked into that, and it turns out that some people are able to swing it, but they are all in support groups. So, we're talking about the general population now. We'll all have to be in Dioxin Anonymous. In other words, and what's more, this is I think, an insupportable idea. There's much more to food than just eating it. I mean, think about your own relation to eating it, cooking it, people who grow it. There's a sense of some cultural, personal relationship to it, and you see it intensely among the Inuit. The Inuit eat an awful lot of animal fat. And they chew on blubber. And in fact, the nutritionists in Canada say that their physiology is adapted to this. I don't know much more about it except what they say. But anyway, I've learned a little bit about the Inuit. Their entire culture is based on how they secure, prepare, and share food. And there's the singular of Inuit is Inuk. And there's a saying, I am Inuk because I eat Inuk food. And the idea of imposing this kind of constraint on them is horrifying culturally. It's also horrifying economically. I learned from one of my Inuit friends the other day. She said it costs 3 times more to eat store food in Nunavut than to eat hunted food. So what we've got here is an option which is blaming the victim and telling the victim, change your diet. Then the other way is what the EPA is doing is these controls. Now let me tell you something. the maximum achievable control technology, they expect over the next 5 years will reduce the emissions from municipal waste incinerators by 98%. 98%. Okay? But remember, we're 10,000 times above the acceptable level. Well, what is 2% that will be left, right? What is 2% of 10,000? 200. So what EPA says, if everybody does the right thing, is that we will bring it down by 98%. And that'll mean we're only at a risk of 200 per million, which I think is unacceptable. Let me put it to you this way. What would it take to come down to 1 per million, knowing where we're at now? 99.9% of the dioxin would have to be prevented from getting into the air. In effect, that's zero. That's zero. So you have to ask yourself, isn't there an easier way to get to zero? Like shutting down the incinerator? There is. Well, you have to ask yourself, so what's the problem there? Why do we have to have an incinerator? We faced that a few years ago when we studied the situation in the Great Lakes states. I'm getting there. And we spent an entire year after we'd worked out where the stuff was coming from, asking what would it cost to close down all the municipal waste incinerators in the 7 states around the Great Lakes, taking into account the bond cost, which that would have to be paid off, taking into account, because most of them, like Ames, were producing electricity, taking into account the loss in the electricity, taking into account what you would do instead, and what we proposed was what we call intensive recycling. Recycling. Everything that can be recycled, which means about 80% of the trash can be recycled or composted. We worked that all out for all the communities. I think the incinerators were burning 11 million tons of trash a year. And we said, okay, we're going to set up an intensive recycling system, costed the whole thing out, including the loss of the electricity, and it turned out that those communities would save $500 million a year collectively in their trash disposal costs. You know, it costs money to dispose of trash. In other words, it makes sense economically. And right now, I can tell you that trash burning incinerators are the most expensive way there is to dispose of trash. And they produce dioxin. So that's where the Ames Nunavut story brings us. Clearly, the thing that looms before you is that you look at all the alternatives, and the only answer you can come to is zero. Zero dioxin. And the obvious, sensible way to do it is to close down the incinerator and find a dioxin-free way of doing what you were doing in the incinerator. Can you do that with cement kilns that burn hazardous waste? Yeah. They didn't used to burn hazardous waste. They burned coal or natural gas. It can be done. And we worked that through, and it might change the price of cement, increase it, because they make money getting rid of the hazardous waste and producing dioxin. It might reduce the price of cement, something like a few percent. Increase it a few percent. Hospital waste incinerators, Well, what do they do in New York now? They closed down about 30 incinerators. They autoclave. The actual hospital waste is minimal, but everything else gets thrown into it. They autoclave it, and then it goes in a landfill. It's perfectly inert. It's been sterilized. And this is now the acceptable way, and fortunately, most of the hospitals are moving in that direction now. Incidentally, I have to tell you, the most of the hospital waste incinerators are in the Midwest. I don't know why it is. There are very few in some eastern states and some western states. The Midwest is loaded with hospital waste incinerators and also municipal waste incinerators. So there are ways of doing it. Well, the last thing I want to do is just tie this up to the broader issue. What are we talking about here? What we're talking about is the idea that the only sensible way to deal with a pollution problem like this is to prevent it, to prevent its happening in the first place. And it turns out that this is absolutely true of a whole slew, well, of all pollutants. Take an example that worked. Well, we did prevent it. Lead. Lead in gasoline was a very serious health problem. It's all been worked out. It's the lead in the blood of kids, where it's been measured for a long time, has gone way down. The amount of lead emitted into the air now has gone down about 95% since 1970. How was it done? Well, how did it happen? The way it was happening was we had lead in the gasoline for the anti-knock stuff, and lead is not combustible. It goes right out the exhaust, so that what was happening was, as you drive down the street, you were putting lead into the environment. And there are certain laws of ecology that I'm partly responsible for them. There's a fifth one. If you don't put something into the environment, it's not there. When we stopped putting lead into the environment, it was gone. Same way with DDT. DDT was banned. There's very little DDT in the environment. In other words, where you change the technology of the production system to eliminate the production of the pollutant, you can do it. You can go to zero. And that's what we have to do in all our major systems of production. Agriculture? Well, the answer is simple. Organic farming. And I don't know, I should tell you, 25 years ago, I think, we did a study comparing conventional 500-acre farms, organic and conventional, through the Midwest. I think one or two were in Iowa. It took us months to find the organic farms. Now we've got farmers' organizations all over the place. And incidentally, what we found was that both farms made exactly, on the average, over a 5-year period, the same amount of dollars per acre. There was a lower yield on the organic farms, but they made it up by not buying all the chemicals. So there is a way of growing food without generating all this stuff. One of the things I want to tell you is that one of the studies we did was with atrazine. You know about atrazine? Of course. Atrazine in your water supplies in Iowa have been known to be correlated with birth defects in humans. And I can tell you, one of the things we found, atrazine doesn't travel as far as dioxin, but it travels as far as Leech Lake, Minnesota, where a lot of Iowans like to fish. So you're now putting some of your atrazine in your favorite fishing grounds up there. And this is another problem. Well, are there ways of growing food without organic? Yeah. I well remember being raised on organic food. Nothing special about it. When I was a teenager in the 20s, 30s, 1920s, 1930s, I ate organic food because everybody ate organic food. Nobody was putting all that stuff on it. It works. It can be done. Well, that's agriculture. Electricity? Well, there is a pollutant-free source of electricity that you carry around on your calculators, the photovoltaic cell that turns sunlight directly into electricity. Can we do something about it? Yeah, it works, only it's expensive. Study was done a long time ago under Carter to show that if the government bought enough photovoltaic cells to use for its own purposes, it would bring the price down very quickly. And we did a repeat on that a few years ago, and showed that if the government spent several $billions buying photovoltaic cells for its own uses, the price would come down over the course of 7 or 8 years to the point where it would compete with utility electricity, at which point it would take over. In other words, and incidentally, that could be done by a stroke of the pen, and something for Mr. Clinton to do as he leaves. Because all he has to do is order the departments, it's an executive order to the departments, you buy photovoltaic cells for the following uses, and that would create a $10 billion a year industry selling at low price. Why do I say all this? Because that's the last thing I'm going to say. This is all connected with the global problems like global warming, in which we are at loggerheads with developing countries. All these treaties, the POPs Treaty, the Global Warming Treaty, the developing countries are saying, look, you got all the benefits from this stuff, now we want to do it. And we can't, you can't expect us to take on the financial burden of doing these expensive things. For example, the POPs Treaty has a provision for doing something about dioxin. And the developing countries said, you're out of your mind. It costs $1,000 to make one dioxin analysis. Where are we going to have the money to do that? Where are the laboratories? And they're right. And this is true right down the line. And we have an opportunity here. If, by the right executive orders, we could show the way and develop, in the case of electricity, photovoltaic cells that are cheap enough to be bought by developing countries, we'd have an expanding market, and they are perfectly suited to do this because you don't need an electric grid with photovoltaic systems. They can all be local. And there are many developing countries where there are no grids, so they don't have to build them. The same way with electric vehicles. That can be done too. In other words, in some sense, the flap over Ames and Nunavut, the relationship between what happens in a very local place with a local plant and somewhere at a distance has to teach us, I think, that we've got to take the step toward fundamentally solving these problems by creating national policies that say we will produce the goods that we need in ways that are required for the health of the environment and the people who live in it. Thank you. I'm told you don't have to go home till 10 o'clock. Is that right? So, up to any questions you've got. Yes?
Dr. Governor, talked about a lot of kinds of problems where there may be great distances between the person causing the problem and the person affected. And I'm wondering what sorts of general approaches you think might be effective in the solution of those kinds of global problems where the distances, ideological distances, spatial distances, cultural distances may be very great between the person affected and the person benefiting from the creation of the problem.
Yeah, obviously, that's a good question. And it's come up very sharply in the POPs treaty. And I'll tell you one of the problems. UNEP, the United Nations Environmental Program that promulgated this treaty, I think made a serious mistake in their approach to developing countries. They said, you should do what we have done. Do an inventory of all your 44,000 sources and do tests and so on. And it made no sense to them. It also doesn't make sense objectively, and I'll tell you why. It turns out that if you look at the U.S. or Germany, any one of the countries that's done a lot of work on dioxin, inventories, sources, and so on, there are a few types of sources that are responsible for the greatest part of the emissions. And the largest single category is the burning of trash. Household trash, what I call domestic trash, stuff that we have to get rid of. Now, how do you do this in Bangladesh? They don't have any incinerators. What happens is, and we've now done work in Mexico. We know exactly what happens. Not exactly, but we know what happens there. According to the government, half of the trash is collected and goes to sanitary landfills. That's what they say. The other half is disposed of informally. Now, what does that mean? That means that you maybe take it to a dump it in a ravine somewhere, or you dump it in your backyard. Eventually, that stuff gets burned. And sometimes it gets burned in a big steel drum made for the purpose. Studies have been done on the dioxin emissions from those. They're huge. There are no controls. And there's an awful lot of plastic, which is a source of chlorine. And so what is happening in a developing country is very simple. You've got to do something about the trash disposal problem. It isn't a question of, in other words, and I've had a friend of mine in Mali wrote me and said the farmers are burning, a lot of plastic is used on the farm now, for rolling hay, mulch, and so on. And that's being done in a lot of places, and it produces a lot of dioxin. What you need to do is to just tackling that one problem of a proper disposal of domestic trash. And what's the proper way? To separate out what you can recycle, glass, metal. Most of the plastic is not recyclable, and you have to attack that by stopping to make all that plastic. And composting the rest, that's intensive recycling. Well, that's an anthropological problem in developing countries. It's not a question of following what Germany does or what the United States does. And I think instead of analyzing our experience, you see, what you look at our data in the United States, and you see immediately that municipal waste incinerators, hospital waste incinerators, and backyard burning are responsible for 50% of the trash, of the dioxin. Well, the thing to do is just start with that. And the way to do it is to talk to the people in the developing country. Let's deal with the trash problem. And there will be ways that we haven't thought of. And a lot of it has to do with scavenging. It was one of the things that happens. And, of course, it all ends up with a question of poverty. But that's another 2 hours. But what I'm saying is we've got to deal with the problem indigenously. And there's a problem developing in Nunavut because they're now importing stuff and they have trash, and they've invented a teepee burner which is producing dioxin, and they'll be in trouble there. Yeah.
If you could please.
As a former researcher and computer modeler, as a former researcher and computer modeler, I'm very curious as to where you got the number for Ames that you used in your model.
Oh, well, that's from the inventory. Yeah, the question is where did we get the number for the emissions for Ames? That's a good question. Here's what you need to know. Very few of the 44,000 sources, exceedingly few, have been measured. It's very expensive. No more than a few percent. So we have to try to do something. So what do? What you do is you take the data from the measurements and work out what's called an emission factor. So you have an incinerator that's been studied, and you know how much comes out and what the conditions are, what kind of control system it has, so on. And you know what the throughput is, how much material is being burned. And you get a ratio of the throughput to the emissions. And that's called the emission factor. And it's so expensive to do the tests anyway that factor generally, what we start with is a minimum and a maximum value that are an order of magnitude apart. And to make life livable, we work with the midpoint. So what we did with Ames is EPA, we talked with EPA about the work they had done on RDF burning plants. RDF is refuse-derived fuel, which is what Ames burns. And it's most of it made about the same way. And they gave us emission factors, a series of them, for different types of facilities, different control systems and so on. Ames has a very old-fashioned ESP, electrostatic precipitator. And so we chose a group of figures for ESPs and averaged it and took the range and the midpoint and applied it to Ames. That's it. Now, the answer to, and I think I said in the beginning, that's an estimate. And what it tells you, if you're Bob Kindred or the council, is maybe we better find out. That's the way to do it. In fact, we wrote a little bit at the back of our report, thinking how the Inuit could use our data, and what we said was, here are various ways of approaching the sources, and perhaps the first thing to do is check it out, get measurements made. And so that's what we did. And I think that's what needs to be done. And it'll be fine. If it turns out where it's very low, that's great. Then we'll change our inventory. But don't forget to tell us. Incidentally, a lot of this we do over the phone, And as I told Bob, we called the Ames incinerator as early as 1995 to find out whether they were really operating, because they are not in the EPA inventory. But that's nothing. The EPA inventory missed a whole category of iron sintering plants, which in Europe are one of the major factors. We put it in. So, yeah.
I've heard that electrostatic precipitators actually can create dioxin. I wonder if you could describe the science behind that.
Well, that's why I said that before. An electrostatic precipitator, it's got nothing to do, well, no, it does have a little to do with the electrostatics. It produces a fine ash called fly ash, very fine particles of carbon. One of the earliest work in this whole business was done laboratory experiments in which it was shown that if you took fly ash and added gases from the flue to it, you could synthesize dioxin. And so it turns out that an electrostatic precipitator has, depending on the design of the furnace and all, has the right temperature zone that facilitates the synthesis of dioxin generally on fly ash. And then some of it comes down in the fly ash, and some of it at that temperature will vaporize and go out the stack. That's it. But any other control system that happens to have that temperature configuration will do the same. The point is, see, in the beginning, when we first moved to St. Louis, to New York from St. Louis, Koch wanted to build 8 huge incinerators, making New York the dioxin capital of the world. And so we started to look into it, and right away we were told by the engineers at the Department of Sanitation, it's no problem. We have a very good, well-designed German device that will burn anything, including dioxin. They weren't too smart. The same engineer went to a Hasidic community in Brooklyn and explained it that way too. We have a very good German incinerator. Anyway, the way we got into dealing with incinerators, I didn't know anything about incinerators. We said, well, we better look into this. And we started to collect data on the relationship between dioxin emissions and furnace temperature. And there was no relationship. And then went back into the early chemical engineering literature and learned about this peak at 300 to 400 degrees. And we published a report saying that's really what should be thought about when you're thinking about an incinerator. And I have to tell you, that's why I didn't mind coming to Ames. The next thing that happened was, here I was a newcomer in New York, although I was born there. Next thing that happened was the Commissioner of Sanitation appointed a committee of my peers, if there are any, scientists, to do a critique of our report. And it was really, well, it was so bad that I got quite a few apologies after a while. But the end of the story is that our theory, a year later, was tested by Environment Canada in an incinerator in Prince Edward Island. They did exactly what needed to be done. They measured the amount of dioxin in the fuel, in the furnace, after the furnace, in the control device, in the stack. And what they showed was there was practically no dioxin coming out of the furnace, but a lot of it at the base of the stack. It was being synthesized. And now that is gospel. But some people haven't picked it up yet. Yes?
We'll take this,
Oh.
excuse me, one more last question, and if you could please hold up for a minute, and then I'm sure Dr. Governor. I'd be happy to answer any other questions or provide the punch and cookies afterwards. Thanks.
I was actually wondering what kind of health problems the Inuits actually faced that they had, and then I also was wondering,
Yeah.
would pasteurizing milk take care of the dioxins that were found in the milk?
No, I should tell you, let me answer the last part first. We measured dioxin in milk right out of the farm tank. But EPA has, just about the same time, did a survey of pooled pasteurized milk from all over the country and got similar results. So pasteurization is very stable. It's very stable. Now, the question of the effect of health on Inuit, much less has been done there than needs to be done. Obviously, it's just there are some wonderful research organizations in Canada, Lower Canada, that have been working with the Inuit, and some of them took milk samples, blood samples, and so on, and some epidemiological work has been done, both on dioxin and PCBs. And what has been observed among the Inuit, aside from measurements, is lower birth weight among the children born of Inuit mothers with high levels of dioxin, and a higher occurrence of ear infections. And that's important because dioxin does a lot more than cancer. It affects the immune system, it affects development, so that it leads to birth defects and so on. And the immune system is really very sensitive to it. And so, and there have been some European studies too, in Sweden, showing that exposure to dioxin leads to, particularly among children, leads to a higher level of infection. That's the most that's been observed among the Inuit. But, there's been very little medical study there. Very little. And besides, it's going to be impossible to do really big-scale epidemiological work. There are too few people. So it isn't something that can just be worked out easily. Okay?